Right, so definite integration is what we've actually already been doing. Where if we've done definite integration with limits on a formula for velocity, that's to well, it finds the area between the curve and the axis, and then we knew that area was related to displacement in that context, isn't it? So this is just a bit more about that, really. Now, definite integration is where we find a value to represent the integral between two limits. Your calculator can find any real definite integral, but may take some time with more complex functions. So the calculator, well, let's just show you the, and I've written here, then you should write this, only to be used to check an answer, because you will get 0 marks even if it's right if you just stick an answer down. But if you know that it's meant to be 135, I mean, this question tells you that anyway, but for some of them you can find out and just check. Now, it's really important that you do these steps to get the marks. The first of which being doing the integration. You put box brackets around, so we go from this funny S notation with a dx saying integrate this to it being integrated with box brackets, and then the limits haven't been applied yet, so we stick the 3 and the 2 like that. I've tidied it up, and so there'll be marks there. You have to, even though it's tedious, write out the subtraction with the limits like this, with the limits substituted in. From that point, and that'll be marks, from that point you can just do it all with your calculator if you wish, but I would suggest very strongly putting that in your calculator and writing an answer down, putting that in your calculator and writing it down with the brackets so that no negative issues can mess it up, and then you get to your answer. So you probably put as required. Now on your calculator, now to be fair, they gave you this answer anyway, but in a normal circumstance you might want to just check that you've got this answer. So it's important to point out that because the format is to give you the integral sign as in integration, you don't even have to do the integration to do this check or put in the integrated form. We're going to put in the original equation, which I have not actually done. Silly. Okay. 8x cubed add 2x and the limits 2 and 3, and what do you know? There we are. So it's a great check that you can do, but it won't get you all the marks just from doing it, because obviously that would be ridiculous. Right, so second example, I'll whiz through it, but you can see what's going on here hopefully. So first step, separate the terms because it's got this dodgy fraction. So I've got 4 over x cubed, because that x there will cancel with one of the x's on the bottom, and I've got minus 1 over x to the 4, which I can write in index power form like this, so that I can apply my rule. And I'm doing it in stages, nice and detailed. Add 1, divide by the new power, add 1, divide by the new power. Then I'll tidy up any negatives. I've got minus, and so that one's negative. You can see how it's all working out. I've got my line here where I've substituted in the limits, worked it out, and done it, and that's right. Now, the last one is where the calculator won't be able to give you a hand, because the limits are in terms of k. Now the question does say your answer will be in terms of k, so that's fine. We just need to integrate it with the k's there. Nothing wrong with that. So x to the 3 will add 1 to the power divided by the new power. Add k. Well, if k is some constant, then if that was an add 2, you'd know it would integrate to 2x, and if it was minus 6, it would be minus 6x. So whatever k is it's going to, if it's just a number, then it's going to integrate to kx. And then the limits for x are for 2k and k. And so we're going to take this and substitute in 2k, 2k, k, k, and begin to tidy it up, sort out the negatives and what have you. And just want to make sure we've done this properly. So we've got 4k to the 4, 2k squared, minus a quarter k to the 4, minus k squared. Be careful with the brackets, you know it's going to be a minus if we expand that. And then I've just done because there's 2k to the 4s, I've got 4 minus a quarter is 15 over 4 k to the power of 4. And that's going to be a add k squared. So there we are. I think there's one more that we'll keep with it. We'll just do in this one as well. So here's similar, but we are going to actually be able to work this out because we're told even though the limits are unknown, we are told an answer. So we can find out what a is as a number. So show that a equals ln k. Right, well, let's do it then. So t over t is 1. 1 over t is just 1 over t. And it's that statement that's an important one that's equal to ln 7. So t, 1 integrates to t, because remember it's got a dt, so we are integrating with respect to t. So if we do just what we'd do if it was dx and we had a load of x's involved. 1 over t is ln t. 2a and a are my limits, and whatever that ends up being, we're told it's equal to ln 7. So I'm going to have 2a as my upper limit for t, add ln 2a minus a, add ln a. So hopefully you realise I've just substituted in the limits, upper and lower, and it's that subtraction that we're told is equal to ln 7. And then it's clearly going to be about sorting out the log laws. So what did I do? Oh yeah, well the a's 2a and minus a made just this one a, and then I've got add ln 2a minus ln a, and that makes a single log as a division, because when you subtract, remember the log laws, the a's cancel, so I'm left with a add ln 2 equals ln 7, and so if I subtract that over to that side, I'll have a equals ln 7 take ln 2, and that is just ln 7 over 2 as the division again. So k equals 7 over 2. Okay, cheers.